The story of technology is, in essence, a tale of how humans and computers have learned to understand each other, from the early punch cards and command lines to today's intelligent, responsive systems. And nowhere is that partnership more meaningful than in public health, where everyday decisions can affect lives. 50 years ago, people spoke to computers in code. Then came the mouse and graphical interface. Later, touch screens, voice assistants, and now AI systems that respond to language, gesture, and even emotion have emerged. Each generation of technology has not only changed what we can do, but also how we think and work with machines. My world lies at the intersection of humans and computers in geospatial intelligence, artificial intelligence, and data visualization. In this video, I will share how human-computer interaction, or HCI, the field of HCI, is evolving to keep pace with the rapid rise of artificial intelligence, what this means for decision makers in public health and beyond, and where this partnership is headed next. Currently, HCI is undergoing a fascinating transition. Most of our daily interactions still happen through screens, keyboards, dashboards, and dashboards within dashboards. Yet, the complexity of our world and what we can accomplish with technology have outgrown these flat interfaces. A public health analyst studying disease risk or a city planner modeling heat and pollution can't afford to click through hundreds of layers one at a time. They need systems that help them think with data, not just look at it. In my work with the World Health Organization, we used artificial intelligence and satellite imagery to predict disease outbreaks. The real challenge wasn't only building accurate models, it was envisioning how these models would have a meaningful impact on human lives. Visualization is that bridge, transforming raw data into something where human insight and machine intelligence can intersect. So that's where we are. Still mainly screen-based, still reactive, but already surrounded by first hints of a more immersive and conversational future. For decades, HCI advanced one interface at a time, from text commands to icons, from desktops to touchscreens. Each step made technology more human. Then AI entered the picture. And when this happened, computers started to understand context, patterns, and even our intent. Tools like chatbots, voice assistants, recommendation engines, translation services, and of course, the ever-powerful machine learning predictions and information extraction brought us into what many call the age of adaptive interaction, where systems learn from us and we learn from them. For those of you with a research mindset towards this topic, there's even a dedicated subfield of machine learning, a branch of machine learning known as active learning. Active learning focuses on how to integrate human feedback in very efficient ways to guide and accelerate the model improvement most effectively. This progress enables AI to evolve through experience, not just from data, but also from human feedback. That's how we move from static algorithms to truly collaborative systems. But the reality is it's still early. Most interfaces aren't yet designed for true collaboration. They're built for control, not conversation. The next leap is about creating partnerships, where humans guide AI systems, and those systems, in turn, amplify human understanding. I've seen this collaboration firsthand. When I worked with the WHO, our models utilized environmental data and demographic data to identify potential outbreaks across the African continent. When those predictions were visualized geographically, local teams or epidemiologists could explore why that risk was rising, such as rainfall, temperature, or demographic information, population density. That kind of interaction with model predictions presented in visual interfaces builds trust and turns data into decisions. In places like Singapore, digital twins are helping to study urban heat islands. They merge satellite imagery, artificial intelligence, and 3D visualizations so that decision makers can walk through virtual neighborhoods and see how changes to vegetation, infrastructure would alter temperature and health outcomes. During my time at Penn State University, I researched, developed, and implemented tools such as CryoViz and GeoDiscoverer. These projects transformed vast, complex datasets into visual intelligence systems, enabling understanding and improvement of public safety. All of these examples have one thing in common. HCI isn't just the user interface anymore. It's the cognitive layer between human intuition and AI reasoning. This new era of interaction is built on top of an expansive technology stack. Earth observation satellites, such as Sentinel, Landsat, and MODIS, are capturing our planet in great detail. AI foundation models, such as NASA and IBM's Prithvi, or Google's Alpha Earth, are capable of summarizing and interpreting petabytes of imagery. Data fusion platforms, such as Google Earth Engine, and of course the vast ecosystem of geospatial and AI-friendly Python libraries, combine environmental, geographic, demographic, and health data. And multimodal AI brings together imagery, language, and sensor data to create a rich and dynamic understanding. HCI is the layer that makes all of this accessible, translating technical systems into intuitive experiences. Without it, even the most advanced AI is just a black box. The frontier of human-computer interaction is becoming more natural and more human. The goal isn't just to make technology easier to use. It's to make it think with us. In public health, this could mean an analyst saying, highlight districts where rising temperature overlap with asthma cases, and instantly seeing those zones appear in a 3D visualization, and then following up with other questions. This type of interaction is precisely what I've focused on much of my career, building systems that help people interact with complex data in intuitive ways. Because when interaction becomes seamless, decision-making becomes smarter. And I can't emphasize this enough. Visual displays need to communicate more than just a simple AI prediction. They must communicate why they are making that prediction. Leaders face incredibly complex choices. Let's take this famous example. When President Obama was told that intelligence agencies believed they had found Osama bin Laden, his decision to attack wasn't based on a single statement. It depended on probabilities, human confidence levels, and the credibility of the people behind that assessment. And the same principle applies to public health. Imagine weighing whether to expand vaccine distribution during an outbreak or whether to close schools to slow the spread of a new virus. Those serious, high-impact choices require more than a yes or no from an algorithm. And then there are the smaller, more relatable everyday decisions, the ones that keep us smiling. Like when Amazon insists you really need that 900-piece STEM roller coaster kit for your child. At some point, you start wondering if the AI's goal is to educate your child, or is it to completely overtake your living room with their stuff? So, even in this simple case, it's valuable to be told by Amazon why they are recommending that set. Whether it's national security, public health, or even online shopping, decisions are always better when predictions, confidence levels, and reasoning are presented clearly and intuitively through good human-computer interaction. And that's how AI will become even more of our ally, not just by producing outcomes, but by explaining them, guiding us, and helping us act with clarity and confidence. For public health organizations, the question isn't whether to use AI. It's how to do it responsibly, transparently, and in a way that people could actually understand and trust. Of course, the current reality brings a few constraints. Hardware is still expensive, connectivity gaps persist, especially in developing regions, where these tools could have the most significant impact. Data privacy and algorithm bias require constant attention. And for many public health agencies, budgets are tight, staff are stretched thin. That's why the next generation of HCI must be built around accessibility, ethics, and empathy. We need lightweight tools that run on everyday devices, hybrid computing models that balance local and cloud resources, and privacy by design frameworks that protect data without slowing down innovation. Ultimately, true innovation isn't measured by who can build the biggest or flashiest model. It's measured by who can build systems that people can actually use, trust, and benefit from. And that's the kind of progress that turns technology into impact. Again, for many public health agencies, budgets are tight and staff are stretched. The promise of AI won't matter unless the tools are accessible, secure, and easy to integrate into real workflows. This isn't just theory. I've seen the power of human-AI collaboration play across very different settings. In the GCC, I'm currently helping design AI systems for environmental monitoring. We'll utilize satellite imagery, sensor data, AI, and geospatial visualization to reveal how trees, buildings, waste, and roads, our built environment, can be managed to protect both environmental and human health. These insights can also help guide urban planning efforts. During my time at Penn State, I led research and implementation on projects such as CrimeViz, GeoDiscoverer, and SensePlace, systems that transformed vast, complex datasets into interactive visual analytics for understanding safety and intelligence networks. These tools enable law enforcement and analysts to explore patterns visually, rather than through endless spreadsheets, making their decisions faster, smarter, and more informed. From outbreak prediction to environmental monitoring and public safety analytics, I've learned one clear lesson. Across all these projects, one theme stands out. Human-computer interaction is the key that turns AI for information into understanding. When systems are built for collaboration, allowing people to interact with data, question results, and view explanations clearly, AI becomes more than just a tool. It becomes a partner in discovery. As we look ahead, the next era of human-computer interaction will be defined by connection, not just between humans and machines, but across entire systems of knowledge. We're moving toward multimodal, adaptive interfaces that can understand speech, sight, motion, and intent simultaneously. Decision makers won't just analyze data on a screen. They'll step inside living digital twins of cities, hospitals, and ecosystems. Within those spaces, AI will simulate outcomes, highlight trade-offs, and help people see the ripple effects of every choice before it happens. In public health, this could mean virtually testing how new housing layouts influence heat exposure and asthma rates, or how improved waste management practices affect local air quality. And beyond direct public health, similar approaches will guide more innovative agriculture, energy efficiency, and climate-resilient planning worldwide. For decision makers in public health, this means moving beyond dashboards and static reports to more dynamic and interactive tools. The future lies in interactive systems that enable you to explore policy impacts before they occur, test interventions virtually, see outcomes in real time, and align teams around a shared understanding. But no matter how advanced AI becomes, the human role remains essential. We set the goals, find the ethics, and interpret the meaning behind every model. The future of HCI isn't about automation. It's about augmentation, building systems that think with us, learn from us, and help us make better choices for people and the planet. We've come a long way from pushing buttons and typing code to collaborating with intelligent systems that help us understand our world in entirely new ways. The future of human-computer interaction, HCI, isn't about replacing people with algorithms. It's about designing technology that listens, learns, and grows with us. Systems that make complex problems a little clearer and our decisions a little wiser. That's the work I'm passionate about. Connecting AI, geospatial data, and human insight to make technology not just smarter, but more empathetic and helpful. Because when humans and computers truly interact as partners, we don't just create better systems, we create better outcomes for people.